Okay, we're going to have a look at surface area of a cylinder, and in particular the curved surface. So that's what we're doing at the moment. We looked at it briefly in a quiz the other day, so that will give you a heads up. So remember I said to think about a can. So here's a can, just an ordinary can, and it's in the shape of a cylinder, and you can see the bottom shape is a circle, and so is the top shape. They're both circles, but what's this shape for the label that goes around it? So let's pull it off. Put the can aside and let's have a look at it. Sure, it was wrapped around the cylinder, so it actually forms a circle. But when I flatten it out, let's see what shape it is. It's actually a rectangle. And the interesting thing is that long side of that rectangle actually wraps around the cylinder, so that long side forms a circle. In fact, its length is the circumference of a circle. And the other dimension of that rectangle is the height of the can. And you can see that there. Okay, so let's close that off. So have a look at my diagram here. I've got the curved, the curved part is here. Let's just give it a bit of three-dimensional feel. So that's the curved part. I want you to imagine you can put your arm through that. So I've taken the label off and you've just got this open cylinder. And remember when we unwrapped it, it was a rectangle. So have a look down here. See this rectangle here? I don't know if you can see that, but I'm trying to highlight it in yellow, which if I draw it over here, you can see it's the same rectangle. Now, remember from our little video that length here, so maybe I'll do it in a different color. See that length there? That matches that length round there, which we know is a circle. So what's the circumference of a circle? Well, we know that the circumference of a circle, wouldn't it be good if I could draw a nice circle? Try that again. Oh, why don't I just use one of the tools, hey? So if I've got a circle, then the circumference of a circle is going to be, so circumference we know is pi d, but in terms of r, it's 2 pi r. So I'm going to use that for my length there, which we know wraps around here. That's it there. So that's why my rectangle has a long side of 2 pi r, and it's probably easy to see that that height there on the can, which matches that height there on the can, which matches that height there on your label, matches that height there. So how do you get area of a rectangle? Well, we know area of a rectangle is length times width. So length times width is right here. Here we go. Length times width. 2 pi r times h. So the area of that label, that curved surface, is, here we go, 2 pi rh. So that's the curved surface. What if you couldn't fit your arm through it? Maybe we wanted, the steel that makes up the can and we want its area. So we would then include the top, that's a circle, and the bottom, that's another circle. So if I was to get the total surface area of a closed cylinder, I'm going to have my two circles. Well, together they make 2 lots of pi r squared, so 2 pi r squared, and that rectangle which we're going to include there. I've got it in the other order because that's how you find it in books. So this formula here, let's just get rid of some of that busyness. A little bit busy for my liking. All right, so see this? This is what you're going to use for all your questions to do with surface area of a cylinder. If it's open at the top, what are you going to do? And closed at the bottom? You're going to lose one of those two circles. So it'd be pi r squared plus 2 pi rh if it was open at the top. If it's completely closed top and bottom, you'll use that one. What if you can put your arm through it? Well, then you don't have any of those. And if you can put your arm through it, it's 2 pi RH. So they're the things we have to consider when we're working surface area of a cylinder. So I hope that helps with your exercise set that you're doing today. Thanks.